Our last topic for this unit is midpoint. Now, while we haven't although we haven't previously discussed the formal definition of a midpoint, we have talked about congruent segments, okay? And we've previously learned that a congruent segment means that you see the dashes that we put on there. That lets me know that they're congruent. We write the statement as AB is congruent with the equal sign and squiggle to CD. And if they're congruent, that means that they have the same length. So if AB is 2 inches, then CD will also be 2 inches. They'll have the same numeric value if they are congruent. Now, a midpoint, when you think of midpoint, I want you to think of middle or center, okay? Because by definition, the midpoint represents the very center or middle of a line segment, okay? And when you place a point, like here at point P, it means it's exactly the same number of units from the center to either end. And in this case, it's 1, 2, 3, 4, 5. Okay, so this is 6 units. This is 1, 2, 3, 4, 5, 6. So there's also 6 units, okay? So what a midpoint does is it cuts a line segment into 2 smaller congruent pieces, okay? So finding the middle, finding the center of a line segment means you're cutting it essentially in half, okay? So obviously we can see from X1 to X2, it's a total of 12 units. And when I cut it in half, I get 6 units apiece, okay? Now, to find the value of where on a number line a line segment might be, we essentially take the average of the two. So for example, there's a couple different ways that we can approach this. So we know so BD goes from -1 to -6. Okay, so that is a total length of 7 units. Okay, now to get the midpoint, we would divide that in half. Okay, because we want 2 equal congruent pieces. So that's going to give me 3.5. So to find the midpoint, I would place the point 3.5 units from either end to get the center. Okay, so 1, 2, 3.5. And if I count from D, it's 1, 2, 3.5. Okay, so I mark this point M. BM is congruent to DM because each segment is 3.5 units. Okay, and on the number line, that value is 2.5. So on the number line, the location of where point M would be placed, so that way BM is congruent to DM, would be at 2.5. Okay. The other way we could do this is based on this average formula they provide for us. So we would do -1 plus, oh, I wrote that backwards, sorry. Okay, -1 plus 6 divided by 2. Well, negative 1 plus 6 is 5/2, and when I divide 5/2, I get 2.5. Okay, so the formula gives us the exact location on the number line. Okay, whereas if you were to count, excuse me, count the length, find the length of the units, the length of the line segment BD, and then divide it in half. This tells you the number of units in each congruent part. Okay, so let's take a look at our example here. Okay, so here we have the temperature at 11 a.m. and 8 p.m. are shown. Find the midpoint of these temperatures. Okay, so when we're given, in this case, we're going to do 20 plus negative 6 divided by 2. Okay, taking the average will give me the specific temperature. Okay, so 20 plus a negative 6, I believe, gives me 14. And when I divide that by 2, I get 7 degrees. Okay, now, if I was to count along the number line, so 20, so negative 6. Okay, so 20 to negative 6 is actually a total of 26 degrees. And when I divide by 2, that means it's 13 degrees from either 20 or from negative 6. And so if I take 20 minus 13, I do get 7. Okay, so it depends on which method makes the most sense to you. Okay, the taking the average, which we call x1 plus x2 divided by 2, the x1 and x2 just represent the two number values where we want to find the middle. Okay, that's very, if you can remember that, that'll give you the exact answer we're looking for. Finding the distance between the two values and then counting or subtracting from either end is more steps, but you'll still get where you need to go. Okay, and then that brings us to the formula for finding the midpoint on the coordinate plane. Okay, you'll notice I have the same x1 plus x2 divided by 2, that same average of the x values. But of course, as we know, on the coordinate plane, we also have y values. So it just means you have to do it twice. So you find the average of both the x and y values. So let's take a look at an example here. Okay, so here, this first question, find the midpoint of AB if A is at negative 2 and B is at 8.3. So add the two x values and divide by 2. Add the two y values and divide by 2. Okay? And that will give you the coordinate of the midpoint. So my x values are always the first two listed, so I'm going to do negative 2 plus 8 divided by 2, which gives me 6 divided by 2, which equals 3. Now my y values are my second coordinate value, so this is going to be 1 plus 3 divided by 2, which happens to be 4, and 4 divided by 2 is 2. So if we were to graph AB, we would find that at the coordinate 3, 2 would divide that line segment in half. Okay? So using the formula, this is your midpoint formula right here. Pause the video and find the midpoint for example 1. So you can see here that after we do the math, our final answer is -1/2, 9/2. Now, be careful because you have two choices that have -1/2 as your first option. So your final answer would be A.